So, speed or velocity is equal to distance over time. Acceleration is equal to the change in velocity, which is final minus initial, over time. We can use triangles to represent them. So let's do some more example problems. So a car takes 10 seconds to travel 5 meters. How fast is the car going? So a car takes 10 seconds to travel 5 meters. How fast is the car going? Yes? You are number 12. No. Hold on. I'm looking at the wrong classroom. Different, Elena. You are 22. So, did anyone find an answer? What'd you get? How in the world did you get that? How can you combine 10 and 5 to get 0.4? You had to type in the calculator wrong. So, speed is equal to distance over time. So here's our time. Our time is 10 seconds. Our distance is 5 meters. So time is 10 seconds. And our distance is 5 meters. How fast is referring to the speed. So we're trying to solve for speed. So we circle speed. And it'd be equal to distance over time. So we plug in our time into our t and our distance into the d. So that'd be 5 meters divided by 10 seconds. And that would give you 0.5 meters per second. Here's another question. How long does it take a car traveling at 10 meters per second to go 100 meters? How long does it take a car traveling at 10 meters per second to go 100 meters? Anyone have an answer? Say it. 10 seconds. So we're trying to find how long does it take. So we're trying to figure out time. A car traveling at 10 meters per second, that would be their speed or velocity, to go 100 meters. So speed is 10 meters per second, and our distance is 100 meters. So making our little triangle, we're solving for time. Time is equal to distance divided by speed or velocity. So we plug in 10 meters per second and 100 meters into the D. 100 divided by 10, 10 seconds. How long does it take a car going 10 meters per second squared to go from 5 meters per second to 25 meters per second? So how long does it take a car going 10 meters per second squared to go from 5 meters per second to 25 meters per second? So which variable does 10 meters per second squared refer to? It would be your acceleration, because the seconds are being squared. So we know we're dealing with an acceleration problem. So we would use the equation that deals with acceleration. Acceleration is the change in velocity over time. To go from 5 meters per second, that's your initial speed, to your final speed of 25 meters per second. So we see that A is equal to 10 meters per second squared. Initial speed or velocity is equal to 5 meters per second. And final velocity is equal to 25 meters per second. And we're trying to figure out time. So circling time is going to be equal to the change in velocity over acceleration. So plugging these numbers in, 25 first to final, so they go into here, minus initial is 5 meters per second, divided by acceleration is 10 meters per second squared. So 25 minus 5, 20, so that's 20 meters per second over 10 meters per second squared. 20 divided by 10 is 2 seconds. Everyone good? So a car accelerates at 15 meters per second squared for 5 seconds. How much did the velocity change? So a car accelerates at 15 meters per second squared for 5 seconds. How much did the velocity change by? Anybody get the answer? Besides Raven, who's been answering all of them. What'd you get, Raven? That's correct. So, triangle, triangle. This is change in acceleration. Or change in velocity. So this is your acceleration. This is your time. So acceleration is equal to 15 meters per second squared for a time of 5 seconds. And we're looking for the change in velocity. So circling this, Vf minus Vi is equal to A times T. So that would be 15 meters per second squared times 5 seconds. And that would be 75 meters per second. So this 15 meters per second squared, this is our acceleration. 15 meters per second squared means you gain 15 meters per second every second. So let's make up an initial velocity. Let's suppose that your initial velocity is equal to 30 meters per second. What this 15 meters per second squared means is that after 1 second, you will increase by 15. After another second, so another second, you will gain another 15. After another second, you will gain another 15. And then after that, you'll gain another, and then another 15 miles per second. So for a total of 5 seconds, let's look at the initial versus the final. So our final was 105 meters per second. Our initial was 30 meters per second. And the change, Vf minus Vi, would be equal to 105 meters per second minus 30 meters per second, which is equal to 75 meters per second. So acceleration is talking about how much you're gaining every second, or some other time interval. Make sense? So let's do a more challenging problem. You're initially moving at 20 meters per second. If you are accelerating at 5 meters per second squared, what would be your final velocity? After 7 seconds. Anyone get an answer? What'd you get, Hunter? Not quite right. Anyone get another answer? What'd you get? Anyone get 55? So one way of doing this would be to start at 20 meters per second. And what this states is so if you're accelerating at 5 meters per second squared, that means every second you're gaining 5 meters per second. So you should not be solving your work like this, but just to demonstrate to see if it makes sense. So 1 second later, you'd be going 25. Another second later, 3 seconds later, you'd be going 35. Another second later, you would be going 40. Another second later, you'd be going 45. Another second later, you would be going 50. And another second later, you'd be going 55 meters per second. So every second, you're gaining 5. So 7 seconds in total. That's how long it would take. Using math to do it. So from this problem, your initial velocity is 20. You are accelerating at 5 meters per second squared with a time of 7 seconds. So your initial velocity is 20 meters per second. Your acceleration is 5 meters per second squared. And your time is 7 seconds. Because we have an acceleration and a time, let's figure out how much our velocity would change by. So let's solve for change in velocity. Vf minus vi is equal to acceleration times time. So that would be 20. That would be 5 meters per second squared. That's your A. Times 7 seconds. And 5 times 7 is 35 meters per second. So 35 meters per second is your change in velocity. That's how much your velocity changed. So in order to get your final velocity would be your initial plus your change. So your initial was 20 meters per second, and your change is 35 meters per second. So that would be 55 meters per second. Hello? Alright. I marked Jake and Wooten here, but he went to the nurse and then went home. Alright, bye. Any questions? Is this making sense? Is this easy? Anyone struggling? The important steps are figure out your variables, figure out what your equation is, plug your variables into that equation, calculate, and figure out what the question's asking for and provide that. Box your final answer and you're done. Would y'all like me to work on some more problems? Or y'all think y'all good? Alright, tomorrow I'm going to pass out homework. But that's it for today.